My name is Phil Nash. I am a developer evangelist for Twilio. That is me online. I am Phil Nash in pretty much all of the places, and that'll be the face staring out at you from all those avatars. Yes, Phil Nash everywhere, even Instagram, GitHub, all those things. Twilio, if I can just tell you a little bit about us, is a cloud communications company. That means we allow you to send and receive text messages and make and receive phone calls using the tools, the languages, and the frameworks that you already know. And I'm going to show you a couple of other things that we do a little bit later. So we're here about communications in a way, because I'm talking about WebRTC. But first, I do want to just make a little check. This is my little kind of, let's get started. If you could grab your phones and kind of send a text message to that number, then if everything's going well, I should probably check I'm on the internet. Yeah, that's a good sign. There we go. Now everything's going well, I promise. If you were to send a text message to that number, your text messages will start to come up on that screen, and that's kind of the power we can do. So come on, behave, obviously, but let's get going. You can set it to, it's 4879944. If you get a text message back, then everything's working. There we go. Things are working. Front Trends does rock. You guys are awesome. Thanks. All right. That's all right. Good stuff. We'll get on to the good stuff. Fine. That's my tech check, though. That means the other things should work, OK? That's the important thing. We have internet connections. We have connections to you guys. It's all going to be fine, all right? Cool. So today, we're talking about WebRTC. So I'm going to give you a quick introduction to what WebRTC is and why we should care a bit about it. A little bit about how to do WebRTC, because I find that's the most painful part of it. And then a little bit more interestingly, what to do with WebRTC. It's not just a simple thing. There's plenty of ideas we can do with this, and I want to kind of hear your creativity and your input and that kind of thing afterwards. So we're really, as I said before, talking about communication, not necessarily text messages or phone calls, but communication. And every single website in the world is trying to communicate something, whether it's the simplest thing, like does every website need to look the same in every browser, or the most complicated thing, like the mess that Facebook looks like right now. That is a lot of stuff to take in. But that is communication between not just yourself, but other people, them, advertisers, everyone, right? And actually, Facebook has started to get on board with WebRTC already in the much simpler, much cleaner idea of Messenger. Now you can make video calls and phone calls from your iPhones, Android devices, and from within your browser. And this all powered by WebRTC. Similarly, Firefox has got on board with this kind of thing and has built communications directly into the browser with their Hello button, which again allows you to start up any kind of chat with anyone you want to simply out of your browser. And finally, this is one of my favorite examples, and this is not out of a browser, but this is the Amazon Kindle Fire devices. And over there, just behind me there, is Amy, one of their helpers. And if you press the Mayday button on any Kindle Fire device, you will instantly get put through to one of these helpers. This was launched in about 2013, so a couple of years ago now. And it meant that people could instantly get help with their Kindle Fire devices. And this, they had an aim for this to decrease support times to less than 15 seconds. And on Christmas Day, after the first day, after it had launched, they managed to get support request times down to less than 10 seconds, about 9 seconds per support request. On Christmas Day, when everyone's unwrapping their things and going, I don't know what this is, I'm pressing the button. And that is all of those things powered by WebRTC, that kind of ability to chat, make video chat, and communicate with other people. So what is WebRTC? Real-time communication. I'm talking really real-time. We've had the idea of real-time in the web, I think, since I started working in about 8 or 9 years ago. But in those days, real-time was kind of, polling over and over to get a result or something, or maybe you used Flash to provide an XMPP bridge or something like that, and then there was long polling, Comet, all those kinds of things. WebSockets we've got to, but that's still, if you want to talk to somebody, that's still making a back and forth trip to a server in the middle in order to make a connection between you and somebody else. Not exactly real time because it has that round trip to go for. And WebRTC, most beautifully, is peer-to-peer. So once you have set up a connection between two browsers, you are connected in the most direct possible way to them, communicating peer-to-peer as real-time as possible. And it's video, audio, and data. WebRTC allows you to send and receive video, audio, and data between two parties. Let's talk a quick bit about support, because everybody likes to see browser logos every now and again. It's not that bad. There's actually I think there's a lot of support for this. We have support in latest Chrome, Firefox, and Opera, and no sign of which yet in Safari or Internet Explorer, or Edge, if we want to call that yet, but I think it's coming in Edge. However, there are actually Apple, of course, is famously kind of difficult to pin down as to whether they're doing something or not in the web, whether it's a standard or otherwise. However, there is a team currently working to support or bring WebRTC into WebKit, and then be like, hey, Apple, go on then. It's there. This is supported by companies who've worked on this for a while, including Ericsson, who I know, like, they made the first actual browser that was compatible, that worked with WebRTC, that was a fork of the Android browser. So they know what they're doing with this, and hopefully this will mean that Apple and Safari will include this at some point. Interestingly enough, they also... no, lost that point. Don't worry. Internet Explorer, on the other hand, are not going to do WebRTC. They are interested in ORTC, which thankfully is only WebRTC version 1.1. They didn't quite agree with the specification or the implementation in the first round, and they wanted to make it what they think better. This is now a new standard being worked on. An evolvement of the standard from WebRTC 1 to 1.1. And hopefully something we'll see in Internet Explorer, Microsoft Edge, when that gets support. There is, of course, mobile support as well. And Android and iOS, actually, the Google team working on WebRTC in Chrome has also produced libraries for Android and iOS for native WebRTC. And also, in the latest Chrome, Firefox, and Opera mobile browsers, on Android, there is WebRTC support as well. Again, no sign of it in iOS Safari just yet, but let's hope for it. So actually there's a lot of places in which you can use this, and we can affect calls, video calls, and data transfer between native iOS and Android applications and browsers on pretty much all systems as well, except for iOS. So cool. So what about the APIs? What are we actually using here? The first one is my favorite and came out quite a long time ago, went through a couple of changes, but is get user media. This is the bit where we get hold of our video and audio data from our browsers, from our phones. It's a simple API. It just gives you a stream of the data with media tracks and things like that that you can add to, take away from. The second, probably the most important part of the entire connection, is, of course, the RTC peer connection object. This is the object that helps you set up that connection to the external user. And finally, there's the RTC data channel, which you can use to then pass arbitrary data, text or binary, over the wire once you have that connection sorted. I just wanted to show you a quick bit of get user media, because I put my slides into a browser for a reason. It's because I can have fun with them. Let's get rid of that. Oops. All right. I'm just going when I saw the screen this size with this looking this great, I was like, I have to use that for something. And if it's not making my face appear on it, then what's the point? So let's let's edit that. And can you see that down there? There we go, it's a bit bigger. So I'm just going to make a video element, call it hello. I'm going to set it to autoplay and set a width of 800 and a height of 600. And that should be all right. Make sure that's set. So we have a video element, cool. And then right down at the bottom, I'm going to get that video. Call it hello, right? There we go. Have that video. And then I just call navigator.get user media. Tell it what I want to get out of it, which is the video for right now. But not the audio, because there's no need for that right now. You can hear me already. And once I get that, I just get a callback with a stream. And with that stream, I'm going to set the video source to a URL made of that stream. If it fails horribly, I'm going to log it to the console. But it won't. So what I'll see is that little, do I want to give you my video thing there? And soon enough, we're back online. And there we go. Giant screen and my face. So that's I added a video element and 2 lines of code. I think that's pretty cool. That's pretty powerful. I'm going to move off of that. Sorry. It's probably a little bit weird. Sorry. So how does it all work? This peer-to-peer connectivity, this new, or fairly new, now usable, I'd say, browser technology. I'm going to give you an example with my 2 favorite people, Alice and Bob. Alice and Bob just want to talk to each other. They want to set up that video chat. And they would like to do so using WebRTC. However, they don't know that they're there. They don't know that they want to chat. Well, they know they want to chat. They just don't know who they can chat to. So the first thing that you have to do with WebRTC has nothing to do with WebRTC. Because you have to work out whether your users are there, kind of presence, authentication, all that kind of thing. So for all that talk about being peer-to-peer and having no servers and everything like that, you're going to need a server. And that server is going to be something that you can authenticate your users to, and something that can tell the other users who's around. So basically, you need to be able to log on, and then Bob log on, and that server is going to say, hey, Alice, don't worry, Bob's here now. And that kind of thing. Of course, it's also going to tell Bob that Alice is there, so they can know that they're online. And this is the stuff that you have to implement yourself. Thankfully, I think with chat rooms and all existing kind of text chat and other kind of chat, there is plenty of implementations of this out there, so it shouldn't be too much of a stretch to find out. So once that has been set up, Alice knows Bob's there. Good stuff. The next thing we need to do is the sexiest part, probably, of NAT traversal. I'm going to leave it to Vanilla Ice to explain this one, because this is all about ice. I'll tell you why in a minute, but firstly, I really like to point out that it's very hard to read there, I think, just because it's a huge screen, but tattooed on Vanilla Ice's knuckles there is wide open, presumably because he likes the open standards that we're talking about right now. But it's about ICE. ICE is the Interactive Connectivity Establishment Protocol. Again, much less exciting sounding than you might have hoped with something named ICE. But basically, this is a way of figuring out, as a peer in a network like this, how other peers can talk to you. We need a couple of things for this. Well, firstly, we need to understand network address translation, NAT. The problem with NAT is that we have all our lovely private networks that we access the internet from, and they tend to probably only have a single public IP address that's public. We need, in order to set up this connection between our 2 browsers, to know an IP address and a port number on which each of those peers can be spoken to over. So in order to find out that kind of thing, we use a stun server, Session Traversal Utilities for NAT. This stun server is effectively a little box in the out in the internet, in the public internet, with which you can Google what's my IP address and port number. That's what I do all the time anyway. A stun server is an automated way of a browser being able to find out, or any kind of peer, being able to find out a public IP address and port number for it. So what do we need a turn server for? Turn is for traversal using relays around NAT. And the problem is certain types of NAT, notably the one I've told is a symmetric NAT, means that once an external service, or once a public service finds out the public IP address and port number of your peer, of your browser, only that can talk to it over that. So it can't share it with your peer. So what we use in this case, if stun fails in that respect and it can only know it itself, you turn to the turn server, which becomes a relay. It becomes a way to send the media through that server and onto the peer, because you can then use that as your public access point. Now, this, of course, means it does become slightly un-peer-to-peer again, because there is that middle point. But this is only the case in statistics have shown about 14% of the cases. It goes up and down. I think one other thing, like symmetric NATs are not that popular, but you have to be prepared, and that's why we have turn servers. So once you have our two peers, our two chat, Alice and Bob, hidden behind their respective kind of private networks, behind their network address translation, they need to find out what they do. And so this is where they go and use a stun and turn server. This is where, within the code, you would add the stun and turn servers that you want to listen to, you want to use to your RTC peer connection object. And that will allow them to start finding out stuff. I've got a little cloud and a Twilio logo in there because we offer stun and turn servers as a service. Other people do. Google has a public stun service that is free to use for testing as well. But if you want to use a globally distributed turn service, then that's what we have. So we have to get, so once you've given the RTC peer connection object that you've created, this stun and turn service, this ICE servers they're called, the browser will start to run off and say, hey, all right, stun server, what is my IP address? All right, turn server, what have you got here? And you get their ICE candidates. And Bob will do the same on the other side. And then finally, we have to tell each other about it. And this is down to signaling, what it's known as. And again, this goes back. They can go back through your original server that you made up your presence with. This is a very useful thing to do with something like WebSockets, as it's a kind of two-way connection of sending stuff on. You could, of course, do it with Ajax and server-sent events if Cornell is watching you. But this is how you do it. So you send your candidates onto Bob. Bob will add those candidates as your kind of remote ones to his connection, and he'll send some back, the ones that he thinks will work for you. And then finally, we go back to that getting hold of our video, our audio. So we get user media. And with those, we have to add the description of that media to our connection object. And once we've done that, we can send those descriptions as an offer. Like these are the codecs, these are the audio and video codecs that I'm using. This is the connection speed I've got, all that kind of thing. We send that to the opposite peer. They send some information back on what you can agree on, and then eventually a connection. And we get a video chat with each other, and it's wonderful. And Alice says hi to Bob. Bob says hi to Alice, and everybody's happy. Or if they're hidden behind weird symmetric NAT, then they get their connection, but they get it through that turn relay. And the media is sent over, and maybe it's not quite as good, but they still get to wave at each other and say hi, and everybody is happy. So in order to sort these things out, we need to work out the user's presence. We need to traverse their horrible corporate firewall network things. We need to get hold of their user video, their audio, their media, all that stuff. And we need to send all that data between the two peers using our other server. And once that's done, we have our peer-to-peer connection. And WebRTC is happening. And that is actually where the fun begins, I think, because that is where we now have our connection between people. So here are a couple of other things that I've come across on the internet recently, which has been some more interesting uses of WebRTC than just simply a video chat solution. This is a project by I forgot that. It's called Waggle Dance, and effectively the idea here is it's a peer-to-peer kind of streaming network in a way. The idea being that if you were going to watch the video Tears of Steel, I don't know why that video, this is just the example. If you're going to watch that video and other people were watching that as well, then once you downloaded chunks of that video from the server, you could be sharing them on to the other peers as well, lightening the load on the server, but increasing the speed of download for everybody watching the video at the same time. The more people watching it, the faster you get to see Tears of Steel. So you distribute the bandwidth amongst people watching the video at the time. There is an example online. That screenshot is from the example. These links will all be in the slides, which I'll post later. But you can go and actually look at the code and see how that's broken down as well. And there's actually a great a video from Reject.js, I think, last year, talking about how that works. Similarly, WebTorrent, similar idea, but it's a streaming torrent client for both Node and the browser, running over WebRTC. So you can store files in your browser using the file API or something like that, and share it with your friends or anybody else you want. This is also, actually, WebTorrent is made by the guy who was behind another project called PeerCDN. PeerCDN is the same idea in the way of Waggle Dance, which allowed other users to your site to download the resources, CSS and JavaScript, or images from other people already on your site. PeerCDN got bought by Yahoo, so don't know that's gone away again. So anyway. Live gaming, gaming, I think, is also a great one. And this is one of the original like WebRTC examples, which I thought was really good. This is CubeSlam. It's a breakout kind of, two-player breakout kind of thing. And you can play against a bear called Bob, if you want. And Bob's quite fun to play against, but it's much better, much more interesting if you play against your friends. And of course, the data being sent for the game between the two paddles is over WebRTC. And of course, you can see your opposing player as well. In this case, my colleague Carter, who's looking a little bit confused as to why I was asking him to play this game at the time. It's all going to make sense, Carter. Don't worry. You get to go on screen. It's wonderful. But as you can imagine, the peer connections between two browsers are going to make that data transfer quicker for your games. So exciting there. And finally, my other example is when you texted in, I got your number, of course, because you texted in. And this is one of the things that we have at Twilio, in which you can, using WebRTC, actually make a phone call from the browser. So I'm going to ring this, and if all goes well, somebody's phone's going to ring out there, and you're on audio, so you can actually say something before I hang up on you, if you want to. So let's make that happen. Hello, call button. That's not happening. How about that? But I've got some horrible... Not divine. All right. We'll skip that one then, because we actually have something more exciting than that. Because recently we announced at Twilio that we were actually providing a product called Video, which is our way to build up real-time video. It gives you the infrastructure and the libraries in order to create WebRTC connections easily yourself. This is the first time I've actually spoken about it, since it's only just been announced and the code is not live yet. But what I can do is show you a little quick demo of this. So if we go over here, can you read that? Is that OK? Cool. If the front row can read it, it's fine. This is a simple web page. It has a header, which is nice. And then just a quick little input and a button and two videos. I also have the source of the video library from Twilio, which, as you can see, is some awkward internal beta version. So don't pay attention too much to that. Simply, also, on the server, I have generated, just over here, you probably can't see that. There's a capability token, which basically means a way of sharing my account details on the front end without anybody else being able to steal them, as that doesn't last long. And also, on line 7 there, you can see creating some ICE servers, and that is getting the details from the Twilio API for my credentials to use their stun and turn servers. So I'm just putting those into the into this view here. As you can see, I'm getting the token, the ICE servers out. So in order to create a connection, what's quite nice is that we don't have to bother with having all those servers I talked about a minute ago. And so we create a Twilio endpoint with the token that we made there, and we give some options as well, which are the ICE servers. And just in case, let's turn debugging on. Always sensible, right? And this actually returns a promise. I'm not going to spend any time talking about promises right now, but they're pretty cool, right? So that promise will return the actual endpoint that I want. Now within here, I'm actually going to create a couple of functions to do a couple of things. One is a conversation started function, which receives a conversation as an argument. And that's going to do two things. I'm going to get my local video. But you've never seen somebody write document dot get element by ID so many times recently. Just get that video element local. And with the conversation, I have the local stream. So what this is going to do is it's going to ask that permission for user media for me and attach it to that local video. I'm going to do one other thing, which is listen for the participant connected event, and I'm going to pass the participant connected method to that, which I'm going to function to that, which I'm going to create now. Participant connected receives a participant. And that will have all the remote stuff. That's our remote participant. It's much less typing this time around, which is nice. Remote video. Have you ever pair programmed with 400 people before? Was that the first thing you found was wrong? Brilliant. OK, so with that remote video, I can then take the participant, that's annoying, participant stream and attach that to the remote video. So that should set up when the conversation starts and ends, right? There's a what? Quotes? Quotes there. That one. Thank you. It's also only called remote. Even better. Brilliant. Thank you, everyone. See, this works. OK, so with our endpoint that we've created, we then need to do a couple of things, which first of all is listen for the invite event. And with an invite, we get an invite. It's wonderful. And the invite, this is just a simple example, so I'm just going to straight up accept it. And that gives me a conversation back in the return to the promise, so I can head on with my conversation started function there. That's good. And then all we have to do after that is grab our person that we want to call and call them. So button. Let's get the button is the call button, and on clicking that, we'll get hold of I love adding false to the end of add event listener. It's wonderful. With that, we'll get the peer that we're wanting to call, and that is document.id, just call. That's correct, right? This is just getting the stuff out of that input and button there. Oh, boy. OK. And with that, we're going to take the endpoint and create a connection. I'm going to forget the exactly what I wanted there. Always have a backup. yeah, create conversation with my peer. And that will return a promise. And to that will be the conversation. So that should be all of that. So all I need to do is start that server up. Got what, sorry? Call button. Oh, I did call it button. Ah, you are absolutely right. Thank you. Even better. OK, great. That was my slides. That is that app. So if I head on over to host 1993, I'll be Phil. See if there's loads. We are making API calls out to the internet again, so come on the internet, stay off the Wi-Fi, everything like that. Come on. This is exactly what you wanted to see. OK, good. The internet has gone. The internet has left me. OK. Who didn't imagine that was going to happen? Brilliant. All right. Effectively, you can make video, though. And I can tell you that the important thing is that like 20 lines of code I wrote there, maybe 30 lines, is a lot less code than you have to write if we go back to think about all of those, like all this diagrams back here. The amount of stuff you have to do to set up those connections, listen to all the events, pass the things around. It's all a lot of busy work. It's stuff that you can do, but it's stuff you want to get out of the way. And that's why we've done this. So just as we're going to, and I'm happy to give demos of this later as well once I get some internet back. But once you have that, so let me tell you, we have a small conference. This is where this is actually getting actually released, and the first people will get their hands on it. So if you like conferences, which you do, you should go to San Francisco in a couple of weeks and go to our Signal conference. If you use that code, you get 20% off the tickets, Nash 20. I just want to finish quickly, because I have run out of time horribly, with the results of that Amazon Mayday thing, because I think this illustrates some of the most beautiful things that can come out of these connections between people and this communication. So it launched in September 2013, and by the April of the following year, 44 of their help advisors had sung happy birthday to somebody who hit the Mayday button. 648 advisors have been sung to by somebody who had hit the Mayday button. 35 of them had received marriage proposals. That's not bad, I suppose. I wonder if that included singing as well. 3 customers asked for a bedtime story, which is nice, although slightly lonely, I suppose. And one customer in particular had a lot of difficulty on their game of Angry Birds. And I can tell you, and it was in the report that mentioned all of these things, that working together with the Amazon Mayday help, that customer passed that level. And that is the power of WebRTC. There's some resources. Thank you. That is all I've got to say. I'm just going to leave this bit up for right now, because I'm really trying to improve how I do this and not run over time, of course. But if you can text a scale of 0 to 10 on whether you would recommend this talk to a friend or colleague, just text it the number. It's the same number we used at the start. 0 to 10 would be wonderful, and it will probably text you back something lovely if you manage to do that. So I will stop talking now. My name is Phil Nash. I'm really excited about the future of WebRTC, and I'm excited about what all of you can do with it as well. So thank you very much for listening.